This is lesson 1.7, rewriting formulas. The volume of a cylinder is given by the formula V equals pi times r squared times h. That is a very common formula that you definitely need to know. Where r is the radius of the barrel or the cylinder, and h is the height. The formula gives the volume V in terms of R and H. In other words, V is on one side of the equal sign and R and H are on the other. If you have values for R and H, you can use this formula to find V, or find that volume. So if you know the radius and the height of the cylinder, you can get the volume, how much that cylinder will hold. However, if you know the volume of the cylinder and the radius, then you can solve for the height. Or if you know the volume of the cylinder and the height of the cylinder, you can get the radius. So you can use this formula in different ways just by rewriting it. Let's practice that. In example 1a, Justin Case is an engineer for a barrel manufacturing company. A barrel is a cylinder. He wants to design a cylindrical barrel to contain 500,000 cubic centimeters of liquid and is considering several different radii and heights. To do this, it is useful to solve the volume formula for height, h, in terms of r. So we're going to solve it for h. They said solve the volume V equals pi r squared h for h. So we are going to put h on one side of the equal sign, everything else on the other side. Okay, so let's do that. So volume equals pi r squared h. We need to divide both sides by pi r squared. The pi r squareds will cancel out on that side, and we are left with h by itself equals volume over pi r squared. That is everything for the volume formula for h in terms of V and R. Now they want you to find the height of a barrel with a radius of 30 centimeters that will contain 500,000 cubic centimeters of liquid. So we know R, and they just gave us the volume. What we don't know is the height. They want you to solve for h, or that height. So we're going to use that formula we just created, that height one. And we can say h equals volume divided by pi r squared. Okay. So h equals, we have a volume of 500,000 divided by pi times 30 squared. Make sure to square the 30 before you multiply by the pi. That's very important. That's the order of operations. Exponents gets done before multiplication. So we have 500,000 divided by pi times 30 squared is 900. If we simplify that some more, it should approximately equal 176.8 centimeters. That is the height of that barrel. Okay, example 1b, we're going to use the period P of a pendulum is the time in seconds that it takes a pendulum to make one complete swing back and forth. So we're going to use the formula for that, where P, which is the period of the pendulum, equals 2 times pi times the square root of L divided by G, where L is the length of the pendulum in meters and G equals the acceleration due to gravity. That typically will always be given to you. In this case for metric, it's 9.8 meters per second squared. So we're going to solve the formula P equals 2 times pi times the square root of L over G for L. So we're going to solve for L. In other words, we want L on one side of the equal sign and everything else on the other side. Well, the first thing we notice is there's a square root. So those square roots we got to get rid of right away, if we can. In this case, we need to square everything, and that will get rid of it. Just like the square root of 3 squared equals 3. If we square everything, we'll get rid of that square root. So let's square the p. So we have p squared. Let's square the 2 pi, and we get 4 pi squared, because 2 squared is 4, and pi squared is pi squared. And then if we square that LG, the square root of L over G. If we square that, that equals L over G. So we're getting rid of that square root. Times L over G. Okay, let's clean it up some more. Let's divide both sides by 4 pi squared. So we have then p squared over 4 pi squared equals L over G, because we just divided both sides by 4 pi squared, and that made the 4 pi squared. If you divide 4 pi squared by 4 pi squared, the 4 pi squareds go away on the one side, they cancel out, and you're left with p squared divided by 4 pi squared equals L over G. Okay, so we're solving this for L, so we need to get rid of the G now. So we're going to multiply both sides by G. So we would say L, that's what we want, equals G times p squared over 4 pi squared. And that's our final way to get the formula P equals 2 pi times the square root of L over G in terms of L. So now they want us to use that. So what is the approximate length of a pendulum whose period is 1 minute? So they want us to use the L equals G times P squared over 4 pi squared. And they say the period is 1 minute. Well, we noticed that it said the period is in seconds. Big flag, periods in seconds. So if they say 1 minute, then we know P has to be 1 minute, but we got to turn it into seconds. So it's 60 seconds. You really got to watch your units. What else do we need to know? We need to know gravity, and they gave us that of 9.8 meters per second squared. So we can say L equals 9.8 times P squared. We said it was 60 for 60 seconds. Squared divided by 4 pi squared. Okay, let's clean that up a little more. 9.8, 60 squared is 3,600 divided by 4 pi squared. We can do the math. We can divide 3,600 by 4 pi squared, multiply it by 9.8, and we should get 893.65 meters. That is the approximate length of a pendulum whose period is 1 minute.